Today, we started lesson 2.9, 1 million taps. We started with the question, Zoe is mailing invitations to a 5th grade party. It takes her 30 seconds to address 1 envelope. We wanted to figure out how many it would take her for 10 envelopes. You guys gave many different theories. 30 times 10. We saw the lattice. We saw pictures of, so what we saw, 10 times 30 equals 300, 300 seconds. Some of you might have drawn envelopes. 1, 2... So if I draw 5, and I know 30, 60, 90, 120, 150, and I need to multiply it by 2, that's 300. Then the next one asked, how many seconds would it take her to address 100 envelopes? So we could say, well, in problem 1, I found that it takes 300 seconds. So 300 seconds equals 10 envelopes. There are 10 times as many envelopes. So 10 times 30 equals 3,000. So it would take about 3,000 seconds. Or 30 seconds per envelope count, or you could have just done 30 times 100. That also equals 3,000. And we also showed you this table. It might have looked something like this. So here's a table. We have time, and that's seconds. And then envelopes. You know, 30, 300, 3,000, 110, 100. So does using the table give you the same answers as the strategy we discussed earlier? Yes. How does the table help you? It models the problem and organizes the information, and it helps you see the pattern. And it helps you think efficiently. So even though there are multiple ways to solve a problem, mathematicians and people try to solve problems in the most efficient way. Efficiency refers to solving problems in a way that minimizes time and effort. So this table minimizes time and effort. So using a table or number sentence is more efficient than drawing a picture because it takes time to draw and label a picture. It's less time to write out a number sentence. So 30 times 1, a lot simpler than drawing an envelope. Or 30 times 10, a lot simpler than drawing out 10 envelopes. So now we were given this page. The 1 million taps. What you needed to do is estimate how many times did you think it would take you to tap 1 million? How many seconds? It's your guess. So however many you think. I think it would take 1,000 seconds. Oh, my comma's in the wrong spot. 1,000 seconds. Then so now you need to tap, you need to time yourself how many times it takes you to do 100. So I'm going to start timing myself and tap 100 times. 162, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. That took me 33 seconds. So, number 3, we just need to think about. So how could we use the 100 times and the 33 seconds I found to figure out how many times it would take to be a million? Lots of different ways. Correct? You were also given this example because number 4 says, look at Maya's work on Math Masters, page 62. Here it is. It says, did Maya use an efficient strategy? Explain your thinking on another sheet of paper. So if you look here, it says it took, so 100 taps times 10 equals 1,000. 1,000 times 10 equals 10,000. 10,000. So it took her 22 seconds to tap her desk 100 times. So she wants to multiply the 100 taps by 10. It gives her, she's going to keep multiplying by 10 until it gives her 1 million. So, how are we going to, is that an effective way? So then eventually she gets down to, it took 22 seconds for 100 taps. So 1 million taps would take 22 seconds times 1 million. Her answer is 220,000 seconds. So you should, on a separate sheet of paper, be explaining your thoughts on if she had an effective strategy or not. Now think about it. How did Maya start? What was her next step? And number 5 says, estimate the time it would take you to tap your desk 1 million times without any interruptions. Use the time it took you to make 100 taps on your desk. Use a strategy that is more efficient than Maya's strategy. Show your strategy on another sheet of paper. So, I know for 100 taps, it was 33 seconds for me. If I created a table like we had, seconds, taps. So we had 100 taps and it was 33 seconds. Let's see, what could I do? Well, if I doubled it, so 66 seconds would be 200. Is that a very efficient way? No. So I'm going to erase that. But if I use what Maya did, and I multiplied it by 10, 100 times 10 is 1,000. And 33 times 10 is 330. I could keep going, couldn't I? So if I multiplied it by 10 again, that would give me 10,000. And then 330 times 10 will equal 3,300. And I could keep going. And that's pretty an efficient way using a table. So you should use Maya's work and your own to show how many seconds it would take to tap 1 million times.